Okay, so what it is we have skulls. And again, those are basically what we got over there. You have a skull like this, clay on it. You won't have clay on it when you get it. But you're going to have a skull like this with no clay on it.
Oh.
And the clay will not be there, so it's a plastic skull, just like Mr. Boney's skull. And you will cut glue sticks, hot glue gun sticks, to a certain length. And the reason you're going to cut them to a certain length is that hot glue gun sticks. You're going to cut them, label them, and you're going to stick these tissue depth markers. And I've got a map. You're going to put them on the skull. 1 through 7, right down the middle of the skull, and then 8, 9, 1 on each side, so you have 2 of each of the 8 through 18. And when you put them on the skull, that will show you how deep the clay, which is going to represent soft tissue on your skull, how deep it has to be. And you will build up the clay. There's a set procedure to do this. It's going to build up the clay that depth at that location. Well, everywhere on your skull is a different depth. So up here is really, that's why you don't have hardly any skin up here. That's why it bleeds so much, because you've got just basically a layer of a couple millimeters of skin and fascia and stuff like that up on the top of your skull. Down here you got quite a bit. Even young ladies, not as much as guys, but the skulls are guys. So you're going to build up clay. And then once you build up the clay, you're not painting it. It will look like a person. Yes, your question.
How come women don't have as much?
Because they're women.
I mean, oh.
Because they're women.
Then it still makes no sense to me.
Why are women the way they are? Because they're women. That's just the way it is. You had to go, the hormones that they got to go to, you'd be the exact same way. Okay, it's just the way it is. I got a granddaughter, 11-year-old granddaughter, just hitting puberty. She is flipping out. She's autistic at that. So autistic and hitting that wrong age for guys. You do the same thing, but you know. You don't do it like girls do, but you still do it. I've taught in middle school, and I will never go back to a middle school to teach. Those kids are crazy. At least by the time you get to high school, you somewhat lined out. Okay.
And they're worse than us.
What?
They're worse than us.
You say one comment and the kid runs out the room screaming and crying. It's really bad. It's really depressing. So you guys at least have calmed down. So what we're going to do is we're going to do the facial reconstruction starting next week. And you've got to be able to cut the tissue depth markers. So stop on that, get into rulers. This is a standard ruler. Obviously, it's not really a foot or 10 inches. This is just showing you blown up so you can see it. There are 2 major scales we use in the United States of America. On the top part of this ruler is inches. Inches are measured as fractions. Fractions being what everybody hates to use. Obviously, it's got a number over a number. The bottom number is divisible by 2. 2, 4, 8, 16, 32. They've actually got them down to 1/64, which is a really small division. If you take a shop class, I've seen Mr. Snodgrass when they have competition out there, when they grade these people for their measurements, they've got to get within 1/64 of an inch to get a good grade on their cuts. So we're talking real small. But inches, again, 1, 4, 8, 16, 32, 64. If I'm not mistaken, this right here is this rule. This is a common ruler, 1/64 of an inch. These are always done as fractions. The problem with the standard measurements, English system, inch system, put your cell phones up. The problem with these, Mr. Spot.
Yes, Mr. Spot.
is feet, the English system, were all based on who was the king at the time they were using this. Okay, whoever the king was, whatever his foot size, that became a foot, and they adjusted from there. When he died and his son or daughter took over, or uncle or aunt, whoever was the next king in line, that was the new foot. Okay, so they were always adjusted by person. At some point in the recent past, 200-300 years ago, they fixed it for this is a foot from now on.
Yeah, that's like the worst way to keep measurement ever.
I'm not disagreeing with you. But about 300 or 400 years ago, the French decided we need to come up with a better, more consistent measurement. Because on inches and feet, how many inches are in a foot? 12. How many feet are in a yard? 3. Okay. It's crazy. You got 3, 12, 36, 5,208. It's so many different numbers. So the French decided we need to have a consistent measurement. Something that is fixed, it can be reproducible, and is easy to play with. Now, they didn't do this in the real world. They did this on a map, but they took the Earth on a map, and they measured from the pole to the equator, theoretically, and they decided that distance would be 10,000 meters. They just made the number up. Okay, now what they actually did is in France, they measured from one city to another city a couple hundred miles away. They did the math and said that's the equivalent. They have since found out that basically they made the stuff up, but that's okay. They had a fixed distance. That is a meter. 1 meter. 1 meter is equivalent to about 39.03 inches, a little over 1 yard. So it's really close to a yard, but it's not quite a yard. But it's consistent.
Kilometers are smaller than a mile, aren't they?
Yes, but that's the reason. A mile, 1 mile,
5,200 feet.
yes. And if you're using yards, 1,760 yards. And like you said, a kilometer is smaller than a mile because a kilometer is not some weird number. A kilometer is exactly 1,000 meters. Is 1 kilometer.
See, that makes sense.
Everything in metric is increments of 10. If you're converting from one unit to the next, centimeters to meters, meters to kilometers, you don't have to pull out a calculator and do major math. Move to decimal place, and you're done. Okay? On this ruler here, the numbers that you see on the bottom, those are centimeters. Centimeters. There are 10 lines between any two numbers, 14 and 15. There's 10 lines. Each one of those lines is 1 millimeter. So there's 10 millimeters for every 1 centimeter. When we measure for the face over there, we're going to be measuring millimeters. Okay? And we're going to measure the smallest one we get, about 3 millimeters. The largest one we cut is going to be less than 20 millimeters. So we're going to be using millimeters. Now, to continue on with this, is we're going to do this whole thing is they calculated out what a meter was. They subdivided it 10 ways, decimeter, subdivided another 10, whatever, centimeters and millimeters, and you can go on farther than that. But everything is related. If you take a centimeter, 1 centimeter, which is just under half an inch, 2.5 centimeters and a little bit. 2.5 centimeters is 1 inch. So 1 centimeter is just under half an inch. But if you take a centimeter and you make a box, one centimeter per side, that is 1 milliliter. Milliliters are a volume measurement. So 1,000 of these is 1 liter. A liter is a little over a quart. Okay? But also everything's related. if you take this 1 milliliter, which is also known as 1 cubic centimeter, you ever heard of 1 cc?
2 cc, yeah.
1 cc, 2 cc, that's what the doctors use. 1 cc is equal to 1 milliliter.
So a 300 cc motor is a 300 milliliter motor.
Yes. Okay? But if you take the box and you fill that box up with distilled clean water to the top, that box now weighs 1 gram. $454 grams is a pound,
Wait,
right?
explain that again?
If you take the box, 1 centimeter per side, that box is a milliliter in volume. If you fill it with water, that now weighs 1 gram.
Oh, okay.
So again, everything is related to the meter. Yes,
So a pound is how many grams again?
454 grams.
It's 453 and change.
You get around 454.
It's like, I think it's 0.8 or 0.9, but.
I'm not surprised you know.
1,000 grams is a kilogram.
I got confused because I didn't use any water, so I thought you just said you fill it up and you equal a gram. And I was
No,
like,
fill it up, it's gotta be distilled water.
yeah.
It's salt water, no, different.
Because I was gonna say like, everything weighs like different densities, so.
Very good, yes, you are correct. Now,
So wait,
go ahead.
it has to be a liquid to be a liter. So it cannot be a liter of,
No, a liter is volume. Whether it is is volume of air, it's a volume of liquid,
sand.
or anything, if it's a volume, volume is a three-dimensional, how much you hold. I can have a gallon of air. I can fill that gallon jug with mercury. I wouldn't be able to pick it up, but I have a gallon of mercury. That's volume.
Gallon of weed.
If you want to, sure. Okay, but it's volume, okay? So, everything is related to the meter. If you take 1 kilogram of mass, it is equal to 2.202 pounds. 30 seconds, we'll be done when we start doing that. What?
That's all I said in a minute.
Yeah, we're almost done. We're gonna hand you the worksheet, go over it, and let you go, okay? So this is all related. Everything is related to everything. Okay? So where are we gonna go with this? A little worksheet. And this has got several reasons we're doing this worksheet. Because we're gonna be doing measurements in about a week. So we're gonna start with this one. That would be bad. All right, so looking at the handout here, and this up here, and I'm sorry this is kind of blurry, I apologize, but hey, this is what you got, right? Okay, so the way this is gonna work, we are going to do some measurements. Remember, the top of the ruler is inches. You gotta measure in fractions. The bottom of the ruler, which is what makes metric so good, we get to use decimals. If you've ever had problems entering calculators, don't get me wrong, some calculators do fractions and it's great, it's bad, and those fractions are great. But most calculators do not do fractions. Fractions would be inches. You can use this on anything, especially decimal. So, what? I got a couple Casios and a TI. Okay, so looking at the first, the one that's got your name on the upper right-hand corner, says name. Which, by the way, that's where your name goes. Okay, there is the first ruler at the top. The instructions below that. On the ruler above, draw a line at 115 millimeters. Okay, remember, 10 millimeters equal 1 centimeter. The numbers on here are centimeters. So if I've got 115
Put in 15.
millimeters, it's going to be equal to 11.5 centimeters. So what I'm gonna do is I'm gonna look on the bottom chart up here, and I'm gonna find 11 and 12. Once you find 11 and 12, the long line in the middle is 0.5. You're gonna draw a line right there. And it says, draw a line there and place an asterisk or a star at the top.
Oh, asterisk or a star.
Asterisk or a star. You got something to write with? They did. My morning class must be eating my pencils. I don't know what they're doing.
Chewing on them, swallowing them.
Here is a pen if you want to try this. It's not mine.
Is your morning class mostly female?
No, actually, more guys than girls. Sorry about that.
Just like this one.
Okay, so that's part one. Part two, draw another line at 3 1/4 inches. Now, inches are the top ruler. 3 1/4 would be, here's 3, 1, 2, 3. The big line in the middle is 3 1/2.
Would be the first big line.
Okay? Half of this, double the bottom number, 1/4. So half between here and here is this line right here. That's 3 1/4 right there. And you would put a hashtag, a tic-tac-toe, a pound sign, whatever you want to call it, you're putting it there.
Okay.
See what we're doing?
So
Every other one of them is just like that. So, take a few minutes to work on this and then we will continue the next part in a little bit.
I don't think I can legally do what I wanted to.
So this was you.
If you have a question that is not a good idea, probably not a good idea. Okay, so
It's like, I don't know, it's just, it probably wouldn't be good because it would probably get like a person in trouble because like it's a picture of someone from a long time ago. I used to know Mr. Poole, like,
Is the one who was hitting on people like this?
no,
all right, so
Yeah,
I picture him passed out drunk in my front yard, like, probably early 20s.
go ahead and get this going. This is a 3-beam balance. It's up here. You're more than welcome when they get done with this to come up here and play with it as long as you use it properly. 3-beam balance, in this case, it measures grams. You can set it up for anything you want to do. This one is 3 different levels, but I mean, they're adjustable. You can replace this. The beams do not have to be in the order they are. In fact, the handout I just gave you for notes, the order is different. You're looking at the numbers, don't look at the order. The way this works is you have, in this case, they call it 3-beam balance because they have 3 beams. The top 2, which in this case is 100 grams right here. It's got little notches so you can only move till it locks. Once it locks, you leave it there. Same with the next one, which is 10 gram increments. So once they get in there, they lock and they stay locked. You do not want them to slide. The lowest one in this case, which is a gram, and the lines between the grams are 1/10 of a gram. So what you do is you slide, this one slides. You have to bump it a little bit to make it slide, but it will slide. So you make sure everything's zeroed out, everything's over in the 0 area. And once it's all in the 0 area, you look at the end of the beam and make sure that it's lined up on 0 down here, which if it's not, there's a screw up here. Down here, there's a screw right over here to rotate it in or out, however you got to do to adjust it. Calibrate it. They actually have set weights that they use, that they know what they are. They'll put them on here and check the calibration on that way too. Once you get it set and calibrated, you take something that you want to get the weight of, mass of, and you put it on the tray, the stage. Okay? You then go over and start by going with the big one first, in this case 100 grams. Move it over 1 notch at a time until it bottoms out. As soon as it bottoms out, back it up to the next previous one before that. And you start doing the next one, which is 10 grams. Again, we'll go one at a time till it bottoms out.
That ain't 10 grams. The other one is.
No, this is 100 grams, this is 10 grams. Don't look at your paper. Paper's different order than this.
Then what's this, the other one?
100, 10, 1. So it bottoms out, so back it up 1. And then you start sliding the 1 gram over till, now this one you're trying to get lined up with the balance. And you may have to play around with it a while, get it exactly where you want it. Okay, once you get it done, what you do is you look at the numbers, and you add them up. So 0 plus 20 plus 1.7. So this is 27.7.
0.7.
1.7, excuse me, 21.7, I apologize, 21.7 grams. Okay, and that's how you work it. And again, if you add it up, you got 100 grams, you got 500 grams, you got 100 grams plus 10 grams. So the most this can take is 610 grams. That's it. And understanding that everything has a mass, that's the definition of matter, everything's got a mass. The smallest you can measure on this is 1/10 of a gram.
What is the mass of air?
It depends. You'd have to look it up. Depends on what the content is. How much oxygen, how much nitrogen. It all depends. Is it cold? Is it warm? Whatever.
I was gonna say, if you take the block off of it, what is it gonna read?
About what?
Remove what you have on top, what will the?
Well, it's balanced. It's balanced to 0. It's not gonna measure. You gotta, if you're gonna measure air, you have to enclose it in something. What you can do is measure a empty balloon, fill it up with air, seal it, measure the filled balloon, and calculate the volume, and you can find out the density. So everything's got a mass. Now, there is a difference, and then we'll go over this handout real quick. There is a difference between mass and weight. We here in the United States, when you go to the doctor, you get your weight taken. That is different than mass. Mass and weight. Weight is related to gravity. Mass is not. Okay, so there's also, depending on what you're measuring it with, this here, and you're going to be needing this here by the end of the second page. This is a scale. It's not a balance, it's a scale. A scale has the body of the machine, and it's got a spring with the platform. This scale is based on where you are when you measure it. If I stand on this puppy, I'm going to get about 270. You go up to the moon, take about 1/6 of that weight. I go to Mars, about 1/3 of what I weigh. Because it's based on a spring and it's based on weight.
1/3 of Mars? I thought it was like
Mars
pretty
is,
close to Earth.
no, it's about 1/3. 25 to 33%, somewhere in there.
It's pretty cool.
One planet's like has more gravity than Earth.
Oh yeah, everything outside of Mars. Okay, so Venus is close, but you can't get to Venus. The temperature on the surface of the planet is like 800 degrees.
Also,
It's also like sulfuric
So,
air.
yeah,
from, like,
sulfuric,
cyanide.
yeah, so you can't go there. The Russians sent a space probe there years ago, and it was only on the surface like 30 minutes before it melted. So you don't want to live there. So this is a scale. What you use at the doctor's office is like the 3-beam balance. A balance, you have a fulcrum, and you have the weight on what you're measuring on one side and what you're measuring with on the other. So a balance, if I measure 500 grams here, it'll still be 500 grams on the moon and 500 grams on Mars. if I use the scale, 1/6 and 1/3. Because the scale is weight, the balance is mass. Mass is not related, it's, gravity is not involved. The scale, gravity is. So the way you're gonna do this, on the handout I gave you, on the first page, and it says page 1 and 2 in the upper right-hand corner, it gives you a picture and you look for the arrow. So the first one, there's an arrow at 300. There is an arrow at 40. And there is an arrow just past the 2, one line past the 2. So I'm going to call it 2.1. So the mass for number 1 will be 342.1 grams. Got it?
Yeah.
The rest of this is one form of this or another. Don't overthink it. Last thing, I'll shut up. We already talked about grams, moving the decimal. Number 7 and 8 down at the bottom. If I have 1 gram and I want to figure out milligrams, 2 ways you can do this. Move the decimal place over 3, 1, 2, 3, or just multiply by 1,000. So if I got something that's 34 grams, it will be 34,000 milligrams. And again, 1 pound, excuse me, I apologize. 1 kilogram is equal to 2.202 pounds. You're gonna need that on the back page. Okay? You got questions, ask. That's all. The rest of the day is makeup, finish your stuff, work on whatever you got. Yes, let me stop this real quick.